So what? Let's find out something useful to do with this thing. So, Lori asked a question earlier about how do we, since the seed resets every time we start STATA, and we don't want to be the same as as our next door neighbor, and we want to approximate even more closely than STATA does true randomness. The way to reset the seed is set seed, and you can type in whatever number you want, but a number that's not too long. I think the limit is like 13 characters, which I guess would be in the Googleplex range. I don't really know how big a number would be, but it'd be set seed, whatever number you want. And once you set this seed number, STATA will use it until you tell it to use another seed number and turn over in terms of generating a random process. So set a seed number, run a random process, and it'll use the seed number, use its long division nonlinear estimator to give you a bunch of random numbers, and you can reset it.
There's a philosophical question about if you're choosing your seed number, why not just choose your beginning number?
That's right. Well, is that a frequentist versus Bayesian question?
Yeah.
About what everything is like? That's right. So just so you know that if you are running things with multiple steps, reset the seed number every time. Or you could set the seed to be some sort of random number if you wanted to. Make sense? Any questions about the seed number? No? So let's clear and let's talk about how to do random selection from the data set. So we put together, with all our hard work, a combined data set of the natality file. Let's load that up now. Whatever you saved it as. I guess I didn't save it, which is so bad of me. I'm just running the do file we just talked about. The result of the graph combine command would have been this for 68 and 2002. So I now have loaded in the combined data set. So the first thing to do in random selection is to generate a new variable. I always call my random variables rand. So as a consequence of having used the uniform density function output from a random number generator, what we have now is data arrayed from 0 to 1 across the entire data set, randomly and evenly or uniformly distributed. So that gives this data set a special property that, just to make things simple, let me explain it this way. So for any, let's say we're working the NAT combined set. So let's say we're working the combined data set, and we have this range of ages across 10 observations. This is the age mom variable, and this is the random variable. And we also have the year 2002 indicator. So what the random number generator has done, because it's a uniform density function, is you can think of it as, of any 10 observations you're likely to get, to make it very simple, one observation is what? I'm going to write it in thick. Okay. So you're likely to get across these observations random numbers which are drawn in equal measure from each bin. So you might have, for instance, 5, 4, 3, 2, 1, 9, and whatever. So basically one drawn from the numbers 1 through 10. And the principle we're going to use is a conditional statement, an if restrictor, to draw out a 50% sample from this data set to see how random selection would work. We have had, from a frequentist point of view, a very simplistic frequentist point of view, created a random set of numbers here over which we have no control. We have not biased the results. We've let STATA's random number generator go and essentially pick for us 5 out of these 10 selections for random selection. So the command we use to get across here is the command there are actually 2 ways you can do this. The first way to do this is the sort of option when you want to select 50% of your data and just want to drop it off. It's using the keep command we discussed in the first section. So you can keep all observations if rand, say, is greater than or equal to 5, or you can generate a marker that would say, yes, keep it and select it, which is the way I prefer because it doesn't drop the rest of your data if the random number is greater than or equal to 5. So this is a way to select 50% of the observations here and take them over into our selected subsample. So let's work this out in STATA now. So what I've already done is created the random number variable and thrown it in here. You can see it in this data set as random all the way on the right side of the board. So as I said, there are 2 ways to do this. You can either keep all observations where a particular condition is true, meaning that random is 0.5 or greater, half the observations, or you can create what I'm going to show you how to do now, which is a marker to indicate that it's part of your subsample. So the way to do that is to create a new marker. So let's just do it for the 1968 observations first. So generate a variable, which I'll call select68, equals 1, if we're making a 50% sample. This is the key to the uniform density function and using the random number generator. So I'm assuming that between 0 and 1, 0.5 approximately represents 50% of the data, which is true, given the histogram I just showed you, how we're going to pick off at 0.5 and move left half of the data we've seen. So we're going to generate a new marker that says yes, if the value of the random number is less than or equal to 0.5, fitting in, and the year 2002 is equal to 0, meaning it's a 1968 observation. Generate a bunch of missing values. Let's do this again. Let's do the opposite for the year 2002. All we do is change 2 simple parameters. And there's one thing I should mention. The reason 68 is at the end and not the beginning of the variable is that you may not start a variable name with a number. It must be a non-numerical character to start a variable name. Just a tip. So now we've built the random selection criteria. And so there are lots of interesting things we could do with this, but I think the best thing to do would be to go over do file and to see what the results of this random selection was like. And if we truly selected things at random, we should expect a distribution very similar to the underlying distribution from the data. So we've advanced to the stage where I'll just talk in do files. So what we're going to do here is, we've already done all this. We've picked our combined data file, we've generated a uniform variable from which we use to select. We've generated a selection variable saying yes, we've selected it from the 68 sample at 50%. Done the same thing for 2002. We've saved this as a new data file, NAT combined select, replace the data file. Now what we're going to do is generate histograms to see what the actual distribution of data is and how it does or does not match the underlying distribution of data. If, as we predicted, the data is similar but not the same, similar to but not the same as the underlying data from natality data sets, we'll be fairly confident that random selection worked. We can count it in the future for really important projects. And that STATA is a great program. So, anybody have any questions about this do file?